handle them. So let's look at the precautions. Do not make the preparations near naked flames or fire. Keep all soap chemicals out of reach of children. Avoid direct contact of soap chemicals with the skin or eyes, and do not taste any soap chemicals. Please note that these precautions are very important because these chemicals can be hazardous to the skin if not properly handled. So please ensure that you take all these precautions as you do this preparation. So we're going to list the chemicals in the order in which we dissolve them in water. Let's look at the first one. The first one is called nitrosol or antisol. You can use nitrosol or antisol. Any of them will be okay. Nitrosol dissolves instantly in water, while antisol takes time to dissolve. Let's look at the second one, caustic soda. The second one is caustic soda. It has the same crystal like sugar. So that's second chemical you will dissolve in water after nitrosol or antisol. Let's look at the third one. The third one here is soda ash. It has a very coarse crystal. Soda ash. That's the third one. Now we'll now go to the fourth chemical, which consists of about 4 chemicals. Any of them can go into the solution of the nitrosol or antisol, caustic soda and soda ash. So here we have sodium lauryl sulfate, which is SLS. Sodium lauryl sulfate or SLS. In place of sodium lauryl sulfate, sometimes you can use Texapon. You can use Texapon or SLS. Any of them will be okay. People are fond of using the two of them at the same time. That is not correct. You can use Texapon or SLS. Any of them will serve. Now, still on item number 4, we have another chemical called STPP, sodium tripolyphosphate. STPP. This chemical looks very much like sodium chloride, that is table salt. So that is the second chemical in the group 4, that is STPP. Let's look at another one again, sulfonic, a very dark and slightly thick chemical, still in the group 4. What we mean by this group 4 is that any of these chemicals can go into the solution of the caustic soda, nitrosol or antisol and soda ash. So let's look at another one again called foaming booster. This is a transparent liquid that can be used to boost the foams of the solution of the soap. So foaming booster. So that is all for the group 4. Let's look at the 5th chemical now, which is called color. Normally this is what gives your soap a green color, and the color that we have here is green. So that's the color we use. The last chemical that we're going to use in this preparation is called perfume, and this perfume, the one we're using here, is particularly called Ampipo. So these are the list of chemicals that we're going to use to do this preparation. Now we're going to move to the second stage of preparation, which is the mixing of the solution. I will show you how you're going to do the mixing properly. Stay tuned as we mix the chemicals in the making of the soap. Thank you. Welcome back. Before we go into the mixing of the chemicals, let me go over the list of chemicals again. Just like I said in the first part of this video, the chemicals we're going to use in preparing soap, liquid soap, are as follows. First one is called nitrosol or antisol. The second one is called caustic soda, and the third one is called soda ash. Please note that the order in which we dissolve these chemicals in water is very important. If you miss the order, you will not get a good quality soap. So it must be in this order. The first one is either nitrosol or antisol. Any of them will serve. The second one is soda ash. In other words, after you dissolve nitrosol in water or antisol, the second chemical that will go into the solution again is soda ash, and this is caustic soda, and this is directly followed by soda ash. The items that make up the 4th chemicals are as follows: SLS or Texapon, STPP, sulfonic, and foaming booster. In this category, order is not important. In other words, you can start with any chemical and end with any one. So order is not important. So all the chemicals that make up the fourth group of chemicals, you dissolve them anyhow, the way you want to dissolve them. Order is not important. But there's one point I want to make very clear here. Sulfonic is not the same thing as sulfuric acid. Sulfonic is a very thick, dark chemical. Sulfuric acid is a transparent, odorless liquid. Very dangerous if it is concentrated. So make sure that you get sulfonic and not sulfuric acid. So after that, the fifth chemical is color and the sixth chemical is perfume. Now let's move into the mixing of the chemicals properly. Let's move on. Alright, you're welcome back. Now we are into the mixing of the chemicals properly. What we are doing now is that we are dissolving nitrosol in water. This is the first chemical that you're going to dissolve in nitrosol. I said earlier that you can use nitrosol or antisol, but what we are using here is nitrosol. Nitrosol dissolves instantly in water, whereas antisol takes time to dissolve. So what we are doing, the production we are doing here now is instant production. In other words, nitrosol will dissolve instantly in water. Nitrosol is a complex carbohydrate, is a polymer. Nitrosol has the same appearance as powdered milk. If you have ever seen a powdered milk before, nitrosol has the same appearance. The volume of water we're going to use for this production is 8 liters, and the salt that we're using here, each of the salt that we're using here measured about 300 grams for each of the salt. So what we're simply doing now is to stir the solution to make sure that no particles of nitrosol is left in the solution. Everything is properly dissolved, and so that we have a homogeneous mixture of solution. So make sure you stir it properly. Now the nitrosol is properly dissolved. The next thing we will do now is to add caustic soda, which is the second salt we're going to add. Caustic soda, we're measuring the water now, and we'll now dissolve the caustic soda in the water. Caustic soda have the same crystalline structure like that of sugar. Very, very sharp crystals. So make sure you stir the solution properly to ensure that all the crystals dissolve in the water. Caustic soda is a very unique substance. When dissolved in water, the container in which you dissolved in it gets warm. Just try to fill the container when you do this kind of experiment. The container feels warm because the reaction is an exothermic reaction. Even if the water you are using is cold water, as soon as you pour caustic soda into it, the container becomes warm. Sometimes it can be very hot and even produce smoke. So this is the second part of this chemical we are dissolving in the solution. We're going to pour it into the solution of nitrosol now. I wanted to watch what's going to happen to this mixture now. You will notice that the final solution of the caustic soda and nitrosol gets thicker. It gives you the same feeling that you get when you pour hot water in a mixture of pap, in a solution of pap. This is what you get. The liquid is coagulating and is getting thicker and thicker. This is because nitrosol is a cellulose, is a carbohydrate material. It's a cellulose. So you have to stir the solution properly so that you have a homogeneous mixture. Alright, from here we're now going to add soda ash. Stir it properly. You can see that the solution is getting thicker and thicker. So from here now we're going to add soda ash to this solution. ensure that you stir the mixture properly so that you will have a homogeneous solution. Just like I said before in the first part of this video, you must learn to protect your hand from direct contact with the salt soda materials by wearing hand gloves. And if you are allergic to odors, please use more nose mask. So we are stirring the solution properly to make sure that everything is mixed. So now we're going to measure volume of water. I will add soda ash to it. We're now going to dissolve soda ash in water. From what we're doing here now, you will notice that all the salt particles, the first thing we do is to dissolve them in water first before we pour the solution to the previously made solution. It is advisable for you to dissolve them in water first before you pour the solution to the previously made solution, because if you dissolve the salt directly into the previously made solutions, some of them will form lumps and they will not dissolve. So the first thing you do is to make a solution of the salt, and that way all the particles will dissolve in the water, and then you add the solution of the salt to the previously made solution. Please, this is a very important precaution you must take, though I did not mention it in the first part of this video. This is very, very important. Dissolve the salt solution, the salt particle first in water before you add the solution to the previously made solution. So what we are doing here now is that we're dissolving soda ash in water, and after that we will pour it into a solution of nitrosol and caustic soda. Ensure that you stir the solution properly to ensure that all the particles dissolve. Alright, we're now going to pour the solution into the previously made solution of caustic soda and nitrosol. The solution of soda ash is neutralizing the whole solution, is making it watery. But don't worry, as we keep adding other ingredients, it's going to thicken up again. So stir it properly to make sure that you have a homogeneous liquid. Stirring is very important here because it makes the liquid homogeneous, and all part of the liquid will have the same fluidity. Alright, we have added nitrosol, caustic soda and soda ash. So we are finished with the first category of chemicals that we want to use. So we are moving into the second category now. That's the category 4. So what we are doing now is that we are dissolving SDPP in solution. SDPP is in category 4. So the first one we're using is SDPP. I told you can use any one. You can start with foaming booster, you can start with SLS, whichever one you want. So we are starting here with SDPP, sodium tripolyphosphate. In this category there is no order. Order is not necessary. You can start with anyone. So now we're going to dissolve SDPP, pour SDPP into the previously made solution of nitrosol, caustic soda and soda ash. Ensure that you stir the solution properly so that you can have a homogeneous liquid. Okay. SDPP has the same appearance as table salt, sodium chloride. Okay, now we're going to measure water to dissolve SLS, sodium lauryl sulfate. Sodium lauryl sulfate. We are not using hexapone here, but we are using sodium lauryl sulfate. It has the same appearance as rice seed. Very, very sharp particles. It takes time to dissolve because the particles are very big. So make sure you stir it properly to make sure that they are well dissolved before you pour it into the previously made solution. SLS, sodium lauryl sulfate, is what we are dissolving in water now. After now, we are going to add sulfonic. We'll add sulfonic. SLS has very big particles, so it takes time to dissolve, so you have to stir them properly. Alright, we are still stirring the SLS to ensure that everything is properly dissolved. Okay, now we're going to add the SLS to previously made solutions. Make sure that you stir it properly so that you have a homogeneous liquid. Alright, now we're going to add sulfonic. Sulfonic is a very thick, dark chemical, honey-like kind of chemical. There's a point I want to make here. Sulfonic is not the same thing as sulfuric acid. Sulfonic and sulfuric acid are two different chemicals. Sulfuric acid is transparent and just no odor. Sulfonic is dark and thick, having the same appearance as honey. So never you use sulfuric acid in place of sulfonic. They are two different chemicals. Sulfonic is a thickener. You can see that the solution is getting thicker now. It's getting thicker. It's getting thicker now, you can see. You can see it's already forming a soap solution. It's getting thicker and thicker. Alright, the next thing we're going to add to it now is the foaming booster. Foaming booster is a transparent liquid. This is foaming booster. We're going to add to it now transparent liquid. very thick now. We only have two chemicals more to add, and that is the color and the perfume. The most popular color that we have is green, but there are several colors around. You can choose the one you want. Different kind of beautiful colors you can use. But here we're going to use green color. In a moment from now we're going to add color to it, and also perfume. The perfume we're going to use for this production is called People. There are different kind of perfumes with fine fragrance. The one we're going to use here is People. As you can see, our soap solution is already formed. This is instant production. That means as soon as you finish adding all the materials, you can start using your soap to wash your materials, your fabric. Alright, this is color we're adding to it now. This is green color. This is green color we're adding to it now. Okay, this is the color green. Sorry about the picture, it's getting dark because the color is green. Ensure that you stir the liquid properly so that the color will go round. Though it takes about 2 hours for the color to properly dissolve in the solution. But there's no problem, you can start using it now. We need to stir it properly to make sure that the color go round. So this is what it takes to make liquid soap. It's a very simple process. Anybody can do it. You can do it for domestic use or for commercial purposes. Alright, the last chemical we're going to add to this preparation is perfume. This is the last chemical we're going to add to it as perfume. And that brings our production to an end. We use a total of 9 items in this preparation. The first one is nitrosol, the second one is caustic soda, and the third one is soda ash. This is followed by SDPP, SLS, sulfonic, and foaming booster. And we also add color and perfume to it. So this is what it takes to make a liquid soap. You can do it for domestic use or for commercial purposes.